हेलो एंड वेलकम अगेन टू फिजिक्स गैलेक्सी। सो आज हम एक क्वेश्चन करने जा रहे हैं जो कि इलेक्ट्रोडायनेमिक्स में आया था इस बार नेट एग्जाम में। एंड द क्वेश्चन इज, इन अ नॉन मैग्नेटिक मटेरियल विद नो फ्री चार्जेस एंड नो फ्री करंट्स, permittivity epsilon is a function of position. If E represents the electric field and mu naught epsilon are free space permeability and permittivity respectively, which of the following expressions is correct? ओके सो ये हमारी कंडीशंस गिवन है और हमको ये बताना है कि विच अमंग द फोर इज अ करेक्ट ऑप्शन. सो दीज आर आवर फोर options. Okay, so if you look carefully into these options, so you'll it resembles with their wave equations. So if you remember, when we do the wave equations, we write del square. So suppose we're writing it for electric field. So del square E equals to 1 over C square dou square E by dou T square. So it resembles, so these options resemble with the wave equation for electric field. Okay, so let's try to find the correct expression by solving the Maxwell's equation. So let's write down the third Maxwell's equation. So we know it's, so the third Maxwell's equation is curl of E equals to minus dou B by dou T. Okay, so this is the Faraday's law. Okay, so what we'll do, so we remember that when we are deriving the Maxwell this wave equation, we take the curl on both sides for this equation. So let's do that. So we take the curl on both sides. Okay, so curl on both sides. So we'll take curl on both sides. Okay, so we'll take curl on both sides. So if we take curl on both sides, so what will we get? So we'll get curl of E. So curl of E equals to minus curl of dou B by dou T. Okay, now we know that curl of E is an identity. So this identity I will write here. So this is an famous identity. So let me write it here. So curl of E equals to gradient of the divergence of the vector field. Here vector field is E minus del square of E. Okay, so this is the identity that we are going to use here. Okay, so I can skip this here, this vector sign. Okay, del square of E. So this is the identity that we'll use here. Okay, so what we'll get, we'll get gradient of the divergence of E minus del square of E equals to minus curl, or I can take here this time derivative, I will take it out, so minus dou by dou T of curl of B. Okay, now what I will do, I will use one more Maxwell's equation here. So I will use one more Maxwell's equation here. Okay, but I have to write it in a general form. So Maxwell's equation I will use here, that is the fourth Maxwell's equation. So that I know it's, so that Maxwell's equation is curl of H is a magnetizing field, equals to dou by dou T of D. Okay, why do you remember that H equals to B by mu, or you can write mu naught because it's a non-magnetic medium, and D equals to epsilon times electric field. Okay, so I will use this magnetic Maxwell's equation here, but I have to substitute the proper parameters here. So I'll write it here. So it will be curl of, in place of H I will write B by mu naught. B by mu naught equals to dou by dou T of, in terms of D I will write epsilon E. Okay, so this is the Maxwell's equation that I will be using. Okay, so this is the Maxwell's equation I'll be using here. Okay, so let me erase this one off and simply substitute this form. Okay, so what I will get, so gradient of divergence of E minus del square of E equals to minus dou by dou T of, so curl of B, in terms of curl of B, already mu naught times dou by dou T of epsilon electric field. Okay, so now I can erase this one off because I have substituted it here. So it implies gradient of divergence of E minus del square E. So remember, so we are doing this mathematical derivation. So because lots of concepts will get cleared, so you have to learn all the steps. So now mu naught can be taken out, so minus mu naught. So it can be written. Now here you had the dou by dou t, dou by dou t. So we can write dou by dou t square of epsilon E. Okay. Now we just have to simplify this equation a bit using some identity, and now we have to use one more equation, basically Maxwell's equation. So let's see. Now you can write it here like this. So I will take this into this side, and so what I will write basically del square E minus mu naught dou square by dou t square of epsilon electric field, okay, equals to gradient of the divergence of E. Okay, so if you can see that it looks familiar to the above expressions given. So first two terms we got. Okay, so first two terms are common in all these equations. Okay, so we got exactly like this one. Okay, so we got like that, but now we have to simplify this term here. Now because this is a charge free medium, so we know in charge free medium rho free will be zero. If rho free will 0, we'll use one more Maxwell's equation. That is the first Maxwell's equation. That is divergence of D equals to 0. If divergence of D equals to 0, it implies divergence of epsilon E equals to 0, because we know D equals to epsilon E. Now again we'll use identity that divergence of a scalar, and when this is in product, that is divergence of product of scalar and the vector, it can be written as epsilon times divergence of electric field plus E dot gradient of epsilon. Okay, so this is what we'll write. Now it's equals to 0. Okay, because divergence of D equals to 0. So from this we'll get, because what we have to we have to substitute divergence of E, so that we'll get from this equation. Now here you have divergence of E, so epsilon divergence of E equals to minus E dot gradient of E, or you can write simply divergence of E equals to minus 1 over epsilon naught E dot divergence of, sorry, gradient of epsilon. Okay, now we can substitute this divergence of E, and we can substitute here. Okay, so let me erase this thing here. So in place of divergence of E, what I will substitute, minus 1 over epsilon. So I will substitute minus 1 over epsilon naught E dot gradient of epsilon naught. So this is what I will substitute in place of divergence of E. Then what I will get, the final equation. So it will be del square E minus mu naught dou square by dou t square of epsilon e equals to gradient of minus 1 over epsilon naught, um or I can say e dot gradient of epsilon. Okay, so let me clear these things. So the final equation will be L square E minus mu naught dou square by dou t square epsilon E. Now here it's minus, I can put it on this side, so it will be plus gradient of E dot gradient of E divided by epsilon naught. Okay, so here actually it was not epsilon naught. Wait a minute. Okay, so it was not epsilon, so there was nowhere epsilon naught. So this is the final equation that we got. So the correct option is this one. So plus, so here we plus, so this is C option is the correct one. So here I missed. So there was no epsilon naught anywhere that I used. So okay. So the third option is the correct option. Del square E minus mu naught dou square by dou t square epsilon E plus gradient of 1 over epsilon E dot gradient of E.